75 on page 515. Log base 2 of x minus 6 plus log base 2 of x minus 4 minus log base 2 of x equals 2. This is a log equation, obviously. Remembering immediately that log is not a friendly function, we will state domain and find the common domain. I highly recommend this method. If not, you have to go back and check. It's up to you. But you have to use one or the other. If you write a domain, what will you have to write? If you want to find a domain, what will you write for the first one to exist? X minus 6 must be a positive number. Log cannot be applied to a quantity that is 0 or negative. So since log is applied to x minus 6, then I have to write that x minus 6 is positive. For the second one, what do I have to write? Very good. Just make a note because this is very important. And what about the last one? What do I have to write for the last one to exist? Very good. So this one means greater than 6, this one means greater than 4, and this one greater than 0. You are looking for the overlap. You can graph all of them. We can graph them if you want and see where the intersection is. Or if you already see it, we can just write the common domain. If you don't, let's graph it so we can see it. Let me know what you want me to do. We want to graph? Very good. So negative infinity to infinity, and 0 is in the middle. Greater than 6, I don't care for units. This is just to help us identify what's happening here. Greater than 6 is this. Greater than 4 is this. And greater than 0 is this. I need to choose all three colors. Yes, the common domain is greater than 6. In other words, if I don't find a solution that is greater than 6, I will have to disregard it and say the equation has no solutions. Now I have to remember what? What is the next step? What do I need to do next? I found the common domain, and then I know that if a solution is greater than 6, it's acceptable. If it's less than 6 or 6, it's not acceptable. What will be the next step? Yes, I have to condense all this. Please tell me how to condense it.
X minus 6 plus x minus 4
Times. Exactly, yes. Very good. Equals 2. The log with a negative in front, the quantity has to go to the denominator. The log with a positive in front, its quantity goes to the numerator. Is that clear? Very good. And now I have to change this into an exponential equation. How do I do that? Yes, but I can do that. But how do I change this from a log into an exponential? And then I'll do that. Of course, I will have to multiply these two using FOIL. But how do I change this log equation into an exponential equation? Okay, let's write the rule one more time. This is the most important concept in chapter 4. Okay, so log base a of x is y is equivalent to where do I start? I have to start with the base, and I have to go counterclockwise. So then, yes, raised to y, not multiplied, nothing. a raised to this power equals x. So then how do I continue? Yes, indeed. 2 squared. Yes, exactly. And now I can distribute x squared minus 10x plus 24 over x, indeed. Very good. Any questions? Okay, now I have to ask myself, what type of equation is this? Yes, I can change 2 squared into what? Yes, and here's my hint for you. Exactly. This is a proportion now, and all we have to do is cross multiply. So x squared minus 10x plus 24 equals 4x. Now, what type of equation is this? So I know how to proceed. It is quadratic, so what do I have to do then? Correct, very nice. So x squared minus 14x plus 24 equals 0. I'm hoping that it's not difficult to factor, but if it is, I will immediately do what? Quadratic formula. Very good. So is it okay to factor? Yes? Alexis? Very good. X minus 2, x minus 12. So then x equals 2 and x equals 12. And of course, I have to be very careful. That's the reason why I stated the domain. And I worked hard for this, right? So the domain is 6 to infinity. Then what do I conclude? I conclude yes for 2? No. And only yes for 12. Good. So we reviewed log equations, but you can say I need more, and we can choose more. If not, we'll move on to another topic, and we can cross this one off the list. Yes? Okay. Let's look at 88, in which we have log of x plus 3 plus log of x minus 2 equals log 14. What type of equation is it? Once I say log, it's very clear. Logarithmic equation, very good. And now the question is, this does not need a domain. It's a number. Log of 14 is just a number. The other two do. Now my question is, what is the base? I don't see a base. 10. Remember 10. And if you look in the graphing calculator, you'll see 10 and log, 10 to the x and log, log x, are on the same key because they're inverses of each other. Good. So what is the domain for the first one? What do I have to state? Yes. And for the other one? Good. From the first one, I have greater than -3. From the second one, I have greater than 2. If we cannot imagine the domain, the common domain, then we can graph it. Can we imagine, or we need to graph it? It's okay. Yes. So indeed, the common domain is 2 to infinity. If I don't get an answer, strictly greater than 2, not 2, strictly greater than 2, then I will consider the equation no solution, having no solutions. Good. Okay, so let's condense the left-hand side as we just did on the other one. How do I condense the left-hand side?
Log x plus 3 times x minus 4.
Very good. At this point, this particular equation does not need to be changed into an exponential one. Here's why. Two numbers are equal and they have the same log. What has to happen to these?
They have to be equal.
They have to equal each other. Log of 15 will not equal log of 15 will not equal log of 14. Log of 1000 will not equal log of 14. So we are not crossing out LOG. We're not simplifying LOG. We're only thinking. Yes, Brian?
It's the common domain, not negative 3 over 0.
Okay, very good. So let's take a look. So 0, negative infinity to infinity. This is negative 3 to infinity. And this is 2 to infinity. I need the common territory. I need exactly where I have both colors, yellow and blue. Because if I pick here, the second one will not exist. If I pick here, both are out of question. So I can only pick here. So it has to be greater than 2. Better?
Yeah.
Okay. Good. So then we concluded that x plus 3 times x minus 2 must equal 14. This quantity must equal this quantity because both sides, the two sides are equal, and they have same log in the same base. Log function is 1 to 1. I can't find two numbers whose log is the same. So now this becomes what type of equation? Correct. So let's distribute. X squared minus 2x plus 3x is plus x minus 6 minus 14 equals 0. Combining like terms, x squared plus x minus 20 equals 0. So if you can factor quickly, we should.
X plus 1 times x.
Very good. So then we have x equals negative 5 and x equals 4. With a big question mark, I go back to the domain and I conclude what? Very good. Again, we cannot really say that we know everything about log equations just by reviewing 2. I would go back and review the other ones. And after I post solutions for test 3 as well. Okay, can we check off logarithmic equations off the list? Do you think we need more? Are we okay? So basically kind of two options. We either look at both sides and say, okay, it's the same log, the numbers have to be the same, or quantities have to be the same, or we remember how to change an log equation into an exponential one. Okay, so let's choose from the topics. So we chose from test 3. What else would you like to continue with? That's okay.
Difference question.
Very good. Good pick. That will definitely be on the test. Okay, difference quotient is in chapter 2. It doesn't matter. Let's choose a quadratic function. Give me any quadratic function that you can think of. And let's find the difference quotient for that function. Very good.
X squared plus 3x plus 9.
Perfect. You are not supposed to memorize the difference quotient, but I hope you remember it, the difference quotient. You don't have to. It's f of x plus h minus f of x divided by h. But two things we have to remember. That every time we calculate and simplify the difference quotient for any function, two things must happen. Can anyone remind us which are those two things?
Denominator should be what?
Yes, h must simplify with one h from the top. That's the second one. Well, what is the first one? All terms from the top that do not have h must go away. because otherwise I will not be able to pull out an h and simplify with the one from the bottom. So all terms at the top, mandatory for any function, all terms at the top that do not have h, and maybe some other terms, I don't care. It's possible that other terms will cancel out. But definitely all terms without h must go away. Perfect. What do I have to determine first, which I don't have? H is a little letter. There is nothing I can do to that. There is nothing I can do to f of x because it's given. So these two, I can't do anything to. The only quantity that I don't have, and I have to determine, is f of x plus h. That one takes time. These two are just replaced. F of x and h has to stay. But this takes some time. So let's determine f of x plus h. I have to determine it before I put it in, before I put all three pieces together. So can anyone tell us how to determine f of x plus h? What do I have to write? What does the function say to us?
X squared plus 3x plus 9.
Exactly. The function says blah squared plus 3 times blah plus 9. And now I know what blah is, and I'm waiting for you to tell me what to write. Very good.
Plus 3 times x plus
Very good.
plus 9.
That's it. Now for this, during the first day of classes, we had our first handout, and we worked on this. Please make me proud, because it's been 3.5 months. And we've seen this every class. How many terms will you give? Good, I'm ready.
X squared. X 2 of x h. X of h.
Okay, no one can simplify, thank you. No one can simplify this, and now I have this piece. So I can put all pieces together. All this is this. I will distribute -1 to all three terms. And then try to simplify. I'm ready when you are. The difference quotient. What do I have to write? This whole thing will replace that. Okay, let's copy it. X squared plus 2xh plus h squared plus 3x plus 3h plus 9. Now remember, we are distributing -1 to f of x. Please tell me what to write.
Minus x squared plus 3x.
Careful to all terms in f.
Minus 3x.
Perfect?
Minus
Very good. So now we know that all terms that do not have h must go away. Otherwise, we have an error somewhere. Good. So x squared goes away. 3x goes away. 9 goes away. A positive with a negative each. How many terms are left at the top? What do they have in common? And they should.
h.
They have to. Because that h will go away with the h in the denominator. So then finally,
2x
2x indeed,
plus h
indeed.
plus 2h. That's 3 times.
Okay, no problem. Is that clear? H times this is this, H times this is this, H times 3 is that. What is the simplified form of the difference quotient?
2x.
It's it. Can we cross the difference quotient off the list? Do we need another example? Are we okay with the difference quotient? Okay, so now let's look at the list and choose the next topic. So far we crossed out logarithmic equations, which is item 3 from here, and we crossed out difference quotient, which is item 6 from here. Yes, Marcus? Equations? Nonlinear equations. Okay, very good. So that is at the end. It's from chapter 5. And let's pick a problem. Section 5.4. Okay. Let's look at 38 on page 588. And that reads x squared minus y squared minus 4x plus 6y minus 4 equals 0. And then x squared plus y squared minus 4x minus 6y plus 12 equals 0. It caught my eye. It looks awful. But let's see. Maybe it's not. So x squared, let me check that I copied it correctly. Sometimes I copy, as you already know, an equation from one problem, an equation from the other. I think I copied it correctly. Good. Okay. Gee, what should I do with this? Definitely not substitution. I can't. So I hope that elimination works. And let's see what happens. If I do this, these two will go away. These two will go away, which is nice. Y disappears. So then I have 2x squared minus 8x and then plus 8. I like it. That's all I want. I want to manipulate somehow these two equations, either by adding or elimination, right? Or by substitution to get an equation with only one variable that I know how to solve. And now you know what I'm going to do. Of course. Thank you. X squared minus 4x plus 4 equals 0. And this should be no difficulty in factoring if you remember our very first handout. And you will say, oh, I know, this is, yes, x minus 2 squared. So it has two options, two solutions, but basically the same, x equals 2. I'm happy, but it's not done, right? So I have x. I have to go back to any of the equations to find y. But it's not a big deal. I will replace x by 2 everywhere. Where do you want to go back? Top or bottom? Okay. So then this is 4 minus y squared minus 8 plus 6y minus 4 equals 0. So I replaced x by 2 all the way. This became 4 and this became 8 with minus in front. I'm still happy because I see negative y squared. These two go away. Plus 6y minus 8 equals 0. Still a quadratic equation. Not a big deal. It needs a little bit of a touch-up, but then should not be difficult to factor. What do I mean by a little touch-up? Yes, I highly recommend it. It's much easier to factor if the leading coefficient is positive. And also use the quadratic formula. It's easier to use the quadratic formula if you have a positive leading coefficient. So y squared minus 6y plus 8 equals 0. And this should not be a difficult situation to factor. And what is it? Very good. So then we have y equals 4 and y equals 2. And now I have to write two solutions. How much is x?
2.
2. When x is 2, how much is y? Very good. When x is 2, how much is y? 2. The system of nonlinear equations has two solutions, 2, 4 and 2, 2. We can go back and check. We should always find the time to check. Always.
What if how many solutions will be?
No, I can't. No. It depends. If there are two circles, then I can say they can only cross in 2 different points. But if it's a hyperbola and a circle, it could be 4. Yeah, I don't know. I can't say. When it comes to two linear equations in 2 variables, then I can say for sure. One solution, no solutions, infinite. But when it comes to nonlinear, no, I can't. Anything can happen. Good. So if we need more examples, we can go for more examples. So this was systems of nonlinear systems of linear equations. Okay, I'm going to have to add this in. Systems of nonlinear equations and inequalities. Sorry about that. I omitted. Good. So we already, but we can cross it out because I have to adjust that. I'm going to adjust it right now. Yes. So equations and inequalities. Good. Next topic.
You just need test 1 equation.
Equations. Yes. We have so many. Okay, let me give you a list. And you choose. Rational, linear, quadratic, absolute value, radical, quadratic in form. At least 7.
Rational.
Rational, awesome. Very good, good pick. So let's start with rational. We just said a rational inside of, yes, come in.
Did you see a wallet over there? Red
Oh,
wallet?
come in and look for it.
I'm sorry.
No problem. A wallet means ID, means credit cards. That's important. Take your time. Look under the table. When I came in, there was nothing.
Okay.
But I think you should look again. Maybe it's under the podium. Maybe you kicked it by mistake. I don't know if you want to come back and look.
Yeah. I'm sorry.
You're sure?
Yeah.
Okay. So we said rational. They are in chapter 1. Section 1.6. 1.6. I'm lying to you. They're in 1.2. Sorry about that. Okay, 1.2. So let's pick a problem. We may have solved it together. I'm not sure. Let's look at 49. On page 120. So 1 divided by x minus 4 minus 5 divided by x plus 2 equals 6 divided by x squared minus 2x minus 8. Is this a rational equation?
Yeah, but it's-
I'm sorry. One over x minus 4 minus 5 over x plus 5 equals 6 over x squared minus 2x minus 8. So if you're using the method that I recommended, then we will do what? First. Yes. Yes. Because it's always easier to have 0 on one side. So this is 1 over x minus 4, minus 5 over x plus 2, but now minus 6 over what? I need to factor it. I can't find the least common denominator before I factor that. And before I state the restrictions. So x minus 2, x plus 2, and x minus 4. Agreed? The sum is negative 2, and the product negative 8, correct? How many restrictions will you have to write? Mandatory. Perfect. Only now I'm ready to find the least common denominator, which is we never multiply the factors in the denominator. Very good. It's not a mistake, but we always want them factored, always in the denominator. We work hard to factor them. We want to keep them that way. Okay, so adjustments, please. I cannot stress enough how important it is to redo your test with solutions several times between now and December the 8th.
So it's x plus 2.
So this needs an x plus 2, correct?
Five needs x.
And this one, you don't have to write anything or just write 1. Perfect. And now? Very good. Right? It's negative 5 distributed to 4, to x and to negative 4. And then? Very good. Now, here's my hint. What do I do next? Correct. So I will combine like terms first. And I have negative 4x, and this is plus 16. Am I correct? (22 minus 6). Okay. And yes, I'm going to cross multiply, and I get the negative 4x plus 16 is 0. And negative 4x equals negative 16, or x equals very good. Let's go back to the list of topics, or more equations. So one more time: rational, linear, quadratic, radical, absolute value, quadratic in form. Maybe I should put the equations, their type, in parentheses for everyone to see. Would that be better? So then linear, quadratic, rational, quadratic in form, radical, absolute value, okay, quadratic in form. Very good. So let's take a look. Those come from section 1.6. Okay. So let's look at 48. Page 185. X to negative 2 minus x to negative 1 minus 6 equals 0. And also for inequalities, I want to be specific, linear, absolute value. Rational, polynomial. When we get to that. Okay. So here it is. X to negative 2 minus x to negative 1 minus 6 equals 0. Thank you. Now you can say, well, this is not necessarily, I don't have to solve it like that because I know that x to negative 2 is, in other words, what? A negative exponent means 1 over x squared minus 1 over x minus 6. So I can solve it like this. True. But let's see if we can solve it. It's nothing wrong. That's fine. But let's see if we can apply, or if this equation is quadratic in form. What will I say? Let y be, in case it's quadratic in form. Which one? Let y be what do you think? It's one of these two. But as long as the other one is t squared. Well, I'm sorry, y squared. So I have to choose the correct one so that the other one is y squared. If it is quadratic in form at all. If at all, it's. So which one? The second one is squared, pretty much. Not really, but it's negative 2. So this is the one that I could denote by y. Oh, okay. I'm sorry. Yes, forgive me. Yes, you're right. Because then y squared will be, when you square this, what do you get? To which power? Correct. Copy the base, multiply the exponents. So x to negative 1 squared, copy the base, multiply the exponents, and get negative 2. Is that okay? So then the equation is indeed quadratic in form because it's just y squared minus y minus 6 equals 0. Again, you don't have to solve it like that. You have another way out for this one, not for all the others. So can I factor this? How do I factor it? Very good. Y minus 3 and y plus 2. And we have two options. But also remember, these options are for y. We have to solve for x. I have to go back to our substitution. We said that y is x to negative 1. So what do I write? Yes, so x to negative 1 equals 3, and the other option? Good. Now I have to go back and replace x to negative 1 by what it equals. What does it equal? Perfect. 1 over x is 3 over 1, and 1 over x is negative 2 over 1. Why am I emphasizing that? Because I like you to see that you can cross multiply. It's a proportion. So this one says 3x equals 1, which gives us x to be very good. And the other one gives us x negative 2x equals 1, and x equals negative 1/2.